All right, welcome to the video. We're on part 2 of 5.1, where we're using fundamental identities. This is 5.1 from the Larson Precalculus book. And we're trying to, basically, I cut off part of this thing, but it's simplifying. It just says simplify this. So you have sine of t plus cotangent of t, cosine of t. When I see something like this, I personally think your best bet is to just try to get it all into sines and cosines. So what I would say, and this is what I think we should do, is we should leave the sine alone. We should change the cotangent into cosine of t over sine of t. Now that needs to be kind of like, that. I don't want that to confuse anyone. That needs to be something that you kind of know. And then the cosine of t from here is staying. So in other words, this became that, okay? All right, so what sometimes we have to do is we sometimes have to find a common denominator. So we kind of hinted at that in class a minute ago, actually. So what we're going to do is we're going to see if we can get this into one expression. Finding a common denominator is a very, very common technique for these and throughout calculus. Like, every single question we're finding a common denominator in calculus right now. And we are pre-calculus, so you would think that that's sort of our goal. So we have sine of t plus, I would say, cosine squared of t, because that's cosine times cosine, over sine of t. Now, a common denominator is going to be to take sine of t and multiply it here. So we're going to multiply by sine of t over sine of t. And I don't know that this is going to work, but I do see that I have sine squared plus cosine squared, so that makes me kind of happy, right? Because now when this multiplies here, I'm going to have sine squared of t plus cosine squared of t all over, we'll just leave this guy alone, that's the common denominator, sine of t. And we're kind of claiming equality here. I don't always write equal signs, but that's sort of what we're doing. What is sine squared of t plus cosine squared of t? Yes, 1. Very good. So you're going to find that these are set up to kind of have nice little magical things like this happen. Not all the time, but much of the time. So a lot of times you're going to see either a 1 minus a sine squared, or a 1 minus a cosine squared, or a cosecant minus 1. If you see like a squared and a 1, there's a good chance that you can just swap that out, right? Or if you see 2 squareds, good chance you can swap that out. So when you see this, you have now 1 over sine of t, and technically you should actually say that that's cosecant of t. So what I'm actually saying to you is that this right here literally equals that. Okay? I like to say literally. Okay? That's the British way of saying it. For fun. Okay, so that literally equals cosecant of t. So that whole complicated thing is just cosecant of t. You got to do something to keep it interesting. All right, let's try a now you try, or a checkpoint, as I like to call it, for fun. Just for funsies. So you're going to see it. You're going to change it probably to sines and cosines, right? And then maybe a common denominator. I think if you try that, you'll be in good shape. Now remember, you can pause the video and give this problem a try, obviously. But remember that a big part of this is just trying something. You get a couple different techniques. I'm going to kind of list them so you can like sub out something with a squared. You know what I mean? Like with a squared, something with a squared. That's a technique. You could do a common denominator. You could factor. You could change to sine and cosine of x. These are all the techniques that we've kind of been using thus far. So let's think about what might work here. I'm going to have you pause the video and give this problem a try. All right, so hopefully you paused the video and tried this problem. My students here in class are not getting a lot of time to do it, but this is 1 over sine of x. Cosine can stay, so I'm going to leave him alone. He's good. But cotangent actually has to be, so times cosine of x over sine of x. Okay. Now, if you take the cosines and kind of multiply them together, right, for this checkpoint, you will have the following. You'll have 1 minus the cosine squared of x all over, these guys are both sine, right? So that's the common denominator, sine of x. Now you look for it and you say 1 minus cosine squared. So we have the important identity up on the board here. And 1 minus cosine squared of x is actually, this is equal to sine squared of x, okay, sine squared of x over sine of x, and that is just sine of x. So that whole thing simplifies, that whole mess over there simplifies to just sine of x. So that's pretty much where we're at. So let's just check, make sure we haven't made any silly mistakes here. On 5.5. Oh, I'm on the wrong page. It's okay. I feel pretty confident about it. All right, so next up is adding them. So you kind of, sort of, already just did this, right? Now it's just saying to find a common denominator. It's being a little more explicit. So this is where I think some people start to have a little trouble. We need to talk about something called the conjugate. I think in your note packet, there's like this big, long blurb about the conjugate, if I'm not mistaken. So you know how like x squared minus 1 is x plus 1, x minus 1? Well, we need to talk a little bit about basically the conjugate. I took it out first, the idea of space. Okay, so you know if you had like 1 over x plus 1 that you could like kind of multiply, what would you multiply by? What's something that you might multiply by in this situation? You might possibly multiply by x minus 1, x minus 1. Okay, we call that a conjugate. Now, you don't do that often in this situation. What you probably did more often was something like this. Hopefully this is something that you've seen. 1 over the square root of x minus 2. That's probably something you've seen a little bit more often. And you need to multiply by the square root of x plus 2 and the square root of x plus 2. The reason is when you FOIL this, should probably use a different color. When you FOIL this out, or just distribute it, I guess, you have x, the outsides and the insides cancel, and you have x minus 4. That whole bottom is just x minus 4. This is called multiplying by the conjugate. So we would call this the conjugate. We would call this the conjugate. So if you look at this first part right here, we're just going to focus on that for now. We have sine of x, we'll just say, over 1 plus cosine of x. If I asked you to come up with a conjugate here, what do you think it would be? What do you think the conjugate of that would be? 1 minus cosine of x. Just change the sign. It's going to do something good because what's going to happen when you FOIL it? Any ideas? 1 minus cosine of x. I don't care about the top. I'm not trying to fix the top, right? I'm trying to fix the bottom. As a general rule, if the bottom is 2 terms, like a 1 minus or a 1 plus or something like that, or two different things, 2 terms, that's not usually good. That's not usually good. We don't usually like that. We prefer to have the bottom, the denominator, to be 1 term. So let's see if this can help us. We still have this plus cosine of x over sine of x. We're not going to focus on it right now. This will definitely be, as you can imagine, the trickiest one we've done so far, which kind of makes sense because they just get harder as you go. Kind of like a classic math thing. Let's get this out of the way. Hopefully you guys have enough space. So here's the magic. The top, we're going to leave it alone for now because I don't see that getting better if I multiply that. So I'm just going to leave it alone for the time being. Just let it be. Because we're not trying to fix the top, we're trying to fix the bottom. We're trying to make the bottom better. So I'm going to leave that 1 minus cosine of x in the top times the sine of x alone. I'm still going to have this plus cosine of x over sine of x. Now, the most important part is going to be in purple. That's this part right here. The whole point of multiplying by the blue, right? The whole point of multiplying by the blue was to use this technique from on the right, which is called the conjugate. And that means that when we do that, we're going to have 1. Wouldn't we really have 1 plus cosine of x minus cosine of x minus cosine squared of x? Does that look right to you? What happens with the plus cosine of x minus cosine of x? They cancel out. That was the point, kind of. That was sort of why we did this. So these are going to cancel, and we have 1 minus cosine of x. So let's just highlight that. Okay, 1 minus cosine of x, or maybe I should just highlight it like this. 1 minus cosine of x, I'm pointing back at my whiteboard here, is going to be sine squared of x, right? I don't know if I need to do this part out. Should I do that out? Like show that? Or that's kind of okay. We just subtract the cosine of x. We have sine squared of x. So that yellow part is going to be sine squared of x. Now what you'll notice is that we have this. We now have on the bottom sine squared of x. Okay, we have over here cosine of x over sine of x. And we have on top here 1 minus cosine of x times sine of x. Can you think of anything that might be a good idea right now? Any ideas? It's on the left side, the left fraction. There should be some cancellation there. You see it? The cancellation. So what we're going to do is we're going to cancel one of the signs from the top and from the bottom. If I cancel out one of the signs from the bottom, I'm just going to scribble out that. This is a lazy way of doing it, but you probably get what I'm saying, right? There were 2 of them, and now there's no exponents. There's just 1 of them. We got rid of 1 from top and bottom. This is really good. We have a common denominator. Everything's just going to fall together. It's going to be so exciting. I'm excited. I don't know about you guys. So we have 1 minus cosine of x plus cosine of x, and it's a common denominator of sine of x, and these are canceling. So we have 1 over sine of x, which is cosecant of x, and that's our final answer. So again, the beginning problem literally is just cosecant of x. That whole thing comes out to just cosecant of x. So that leaves us with this checkpoint, which I will pause and ask you to try. And I'll actually pause for a little while this time, because this is where, it starts to get a little dicey. We're at that point where it's like a tipping point, So let's pause the video and give this one a try. Make sure you try this one if you're watching at home. This is where I think sometimes we start to lose people. So good luck. Okay, we're back. And again, if you haven't paused the video, I urge you to try this one, because this is one of the trickier ones. And there's a couple things going on here. We're going to multiply by the conjugate here. 1 plus sine of x, or theta, I guess. 1 plus sine of theta. I'm going to go fast just because hopefully you tried it and you already have this all written out, or at least something close to it. And you can always rewind the video if something's not looking good. We had to multiply by the conjugate twice. Now I'm going to show you that the bottom is going to come out to 1 minus sine squared of theta. And that's going to be in both cases, which is a common denominator, so that's good. And now the top here is going to have this 1 minus sine of x, and the top here is going to have 1 plus sine of x. And now you keep the top, you keep the bottom and you add the top. But isn't the bottom really also known as cosine squared of x? So the bottom is actually cosine squared of x. And if we keep the top, we have, or if we add the top, 1 minus sine of x plus 1 plus sine of x. The sine of x's cancel, and you get 2 over cosine squared of x. Now this is a full credit answer right here. However, if you're ever looking in the back of the book, a lot of time, the back of the book will change this to 2 secant of x squared. Okay? So either one of these is okay, but often they won't put a cosine, they won't leave it as a fraction, because cosine's reciprocal is secant. So if cosine's in the bottom, secant's in the top. Okay? So again, if you get to the blue, we're good. We're fine. Any questions? Because if you have questions here in class, the people watching the video next year, they're going to have questions too. So I'm ready for them if you have them. Okay. I want to try to get through one more. I realize this is a decent amount. This is really not too bad, because all this is asking you is rewriting this so it's not in fractional form. Whenever you see this, if you're in the book and you see this, this is a calculus symbol. I'm almost always going to do these problems because this is a skill you'll need in calculus specifically. So this is a symbol for calculus, basically. And I wouldn't be doing myself any favors, because I'm teaching AP Calculus now, if I didn't get you to solve this. They're having trouble solving trig equations in calculus now. They're like, uh-oh. And I was like, well, we did do it last year. So let's look at this. It's actually not bad. You want to get the fraction out of there, no fraction, okay? So you're going to multiply by the conjugate. Are you sensing a theme with this conjugate thing? It's a big deal, okay? It's important because it fixes a lot of issues. 1 minus sine of x will be the top, and then 1 minus sine squared of x is the bottom. Notice how I'm not really foiling that out. I just kind of know. 1 minus sine squared of x is cosine squared of x, because we just subtract the sine squared of x from the other side. So that's going to be 1 minus sine of x over cosine squared of x. Now, all they said was to write it so it's not a fraction, right? As long as you do that, you're good. So let's make this 2 fractions, and then let's see if we can convert them to not be fractions. So we have 1 over cosine squared, and we have sine of x over cosine squared. Let's look at each of these separately. I think you're probably okay with that. What would this be, 1 over cosine squared? What's cosine's reciprocal? Secant. So this is just going to be written as secant squared. So one fraction is gone. We're halfway there. And then this guy right here, minus. What is sine over cosine? This might be a little tricky. So this I want to make sure I don't miss. I don't want to miss the mark on this. This is really sine of x over cosine of x, cosine of x. Can we focus on this? What's that? Sine of x over cosine of x. Tangent of x. So we're going to write tangent of x for that part. And then we're going to focus right here. There's still a 1 here, right? What's 1 over cosine of x? Secant of x. And that's it. We did what they asked us to do. There is no fraction. Okay, so this has got to be the end. We're going to try to pause the video and give one more a try. So can you try to do this checkpoint here? Pause the video and give this problem a shot. Clearly the conjugate is going to come in again. As long as there's no fraction, like on your quiz, I know there's going to be one that says this and it says no fraction, right? Because you don't know how to it says simplify, right? But simplify is not clear. So sometimes it's like, hey, no fraction. Or it says, hey, one term, no adding and subtracting, right? So anyways, we get a wrap. We're pretty far over here. Oh, we're going to be under 20 minutes. I'm excited about that. So we'll see you guys in the next video. Make sure you smash that like button, tick the notification bell, and subscribe. We'll see you in the next video. Peace.